Awesome. All right. So, hello everybody. I'm Vineet. I'm an MD PhD, currently supposed to be finishing up third year and going into fourth year. I'm currently considering neurosurgery as my residency. And one of the biggest reasons why I've loved my time here at Emory is probably mentors and choosing the right mentors, choosing the right guidance to go about research, to go about medicine. So I'm really grateful to have the opportunity to talk to you all about mentors and discovery projects and projects. So I've been fortunate to have, I think I did the math, and about 9 mentors over my time where I've spent at least 8 months with them. And really their mentorship and choosing them to fit my goals and fit my personality and style got me through a lot of the tougher parts of med school, of grad school, of research projects. So I think it's really, really important to be thoughtful about choosing your mentors. And what I'm going to try to do is give general principles for how you pick a research project and pick a mentor. It's really going to depend on a case by case basis, but these are the general principles that I think have helped me through my time here. All right. And at any point, feel free to email me or tweet at me, I guess is how I say that. And let's go ahead and begin. All right. So the first thing you really, I think, have to ask yourself is, what is research to you? And what are your goals with research? The NIH budget is massive. So I believe this fiscal year of 2020, they came out about $42 billion, inflation adjusted. There's a lot of money in medical research. That is probably a really good reason to get into medical research. But on the flip side, there's also really, really cool technologies, really, really cool results, scientific insights that come out of research, independent of whether the NIH is supporting it or not. So I want to highlight that there are a diversity of projects that people can do for discovery or PhD or MSCR or MPH. Those are the big ones that I can remember. And we're in Atlanta, so there's a lot of opportunities across the board: biomedical research, robotics research, everything in between. So what you got to ask yourself is, what is research to you and what are your goals with that research? Because discovery really, really is trying to get you to think about ways to improve patient care with your research, but there are other goals that you might also have. So is research a way to improve patient care for you? Is it an opportunity to differentiate yourself in residency interviews? Because that's actually a really, really powerful way to set yourself apart from pretty much everybody. It's really hard to choose the exact same project topic as everyone else interviewing for your same residency. Do you want a little bit of that really, really good NIH money? Do you want to be sure to have that in your pocket through your career so you can rely on that to keep you through your clinical practice? There's a balance that you can have where you're partially paid by the clinic and partially paid by NIH money. That's a reason for some people. It's a chance to learn a skill you've always wanted to learn. That applies to discovery, that applies to research in general, always. And is it that thing you just have to check off to get into the residency you want? Maybe you want to go to a specific school that seems to be research focused, but you don't like research, but you just got to check the box. I would ask you to do some soul searching and see if that's the right school for you. But at the end of the day, maybe it is the right school for you and you need to get that research project there as a checkbox. And ultimately, some folks might just do it for exploration of questions at the edge of understanding, that optimistic, bright-eyed, bushy-tailed way of inquiring about the world, because there's so much left for us to know, and there's this gut feeling that if we know more, we'll be able to treat our patients better. So I'm going to be giving this advice from this last perspective, and that's because I pretty strongly believe that if you focus on that last perspective, all of the above goals are reached. Everything else kind of falls into place if you're constantly asking questions at the very edge of your understanding. And ultimately, through discovery, through PhD, through whatever research opportunities you're going to go through, it's okay to change in any direction. Listen to yourself. Listen to yourself. If you thought you like research, but really, really don't like it during these experiences, that's that's a very valuable lesson. And so change directions, make research, make a different research goal, maybe even take research out of your career. If you go into discovery really dreading research, but choose just the right project or just the right mentor, who knows, maybe that will actually spark a lot of interest in research. That happened to a sizable portion of my class, my original class. Is discovery went from being a check mark thing to a, wow, there's actually a way to merge this with clinical care. So I want to take a step back and really get on the same page about what research is, at least my perspective on what research is. There's this old, a whole old set of physics conferences where all the big wigs would talk to each other. So this is Einstein talking to Marie Curie, and they're just talking about what could be the intersection of different ideas that they all have. And a different way of looking at what research is really trying to explore the landscape. So there's a lot going on in this figure, but what I'm trying to convey here is, if we're trying to find the peak of the tallest mountain and we're going hiking, you want to explore. You have to explore, because you might be right here next to a local maximum. You might be close to the second highest peak, and you're going uphill and it feels really, really hard. And once you get to the top, you realize, wait, no, there's a better solution. There's a better place for me to be to achieve my goals. This middle zone is pretty tough. You have to actually go through a little bit more hard work to go back down. It looks like you're going to lose progress, just so you can then work even harder to get to the ultimate end goal. This is research in a nutshell. There's a lot of ways that this figure applies to things, but ultimately it's the act of exploration. And how do we explore solutions to the questions that we have? So one thing that I'll stress, at least what I've seen in my experience with folks that really thrive in research, is loving the questions and not necessarily loving the answers. Most of your questions won't really have answers. I can't stress how important that is. There are very few people that come out of discovery satisfied with their answer. Nobody ends with saying, okay, well, I'm done. I answered my question. I'm good now. And one thing that can really help you in a long-term research career is really thriving in uncertainty. When you answer a question, it typically leads to even more questions. So how do you chase those questions in a way that you feel satisfied and you're not just constantly chasing the thing that will get you a sure thing? Obviously, this is a very idealistic way of looking at research, but we're in med school, so this is the time to be idealistic. So another thing is the nature of research is really, really changing. So the old school way of designing a very careful experiment so that you could use some pretty standard statistical tools is, I think, important. It has a very important role in how we do scientific work. But there is this very new way that we're living in an exciting time where we're actually able to use advanced statistical tools. We're able to leverage modern math in a way that can actually be tailored to whatever questions you have and whatever data you have, so that you can piece out exactly what the answer to a question is from a data set that's kind of just out there. This is done pretty rigorously. I won't spend too much time talking about this, but why I mention this is research is really going through a major transition. And so doing your discovery in a way that prepares you for that, I think, is crucially important. And there are initiatives coming through the med school where that kind of new way of thinking is going to be the primary focus. So general factors that go into a decision of how to choose your mentors and how to choose your project. This is just a timeline. It may be a little hard to read, but this is a typical timeline for a PhD student. This is over 5 years. It takes about 2 years to really choose your topic. And it takes another 2-3 years to really figure out what your ultimate dissertation, what your big piece of work is going to be. And then you try to scramble and write it in your 5th year or 4th year or 6th year or 9th year. So this is a really long timeline. And the goal of discovery, the goal of MSCR, the goal of MPH is to try to condense this as much as we can into a doable thing in a few months. So that's really tough if you're looking for results. So think of research more as a process. You want to actually learn the skills needed to do research. If we go back to our analogy earlier about hiking and finding the tallest peak, research, especially discovery research, is about learning how to hike, learning what tools you need, learning what shoes you need to wear, learning how to go uphill, downhill. Because ultimately, it's not where you end up at the end of those 5-6 months. It's the fact that you learned the process needed. You learned how to actually explore in this scientific way that comes back and actually helps you. There have been countless people that had discovery projects that were probably not productive that actually prepared them very, very well for the research that they were going to do in residency. I'm talking from at least anecdotal experience with my own classmates. And like I said, 5 months isn't much time to do a whole project. And if you're diving in, and it is possible to dive into a project that is ready to publish, where you come in and you do that last bit of work to get published. It may work out, but typically you're actually then bypassing the toughest part of research. So that may work if you're interested in getting a checkbox of a research project, but you'll actually, I think, be shortchanging yourself in the long run to not actually do the toughest part of the research. A very important way that discovery and these research projects help you is expanding your professional network. Your mentor is a chance to find a lifelong advocate. A good mentor is someone you keep in touch with essentially for the rest of your career, and they'll really help set the tone for what opportunities open up for you. Just because you have a mentor and the mentor doesn't turn out the best doesn't mean you're stuck in that path. You can go find a good mentor, but good mentors really bring you into their network of professionals, and they can then help slipstream you into a project that is appropriate for you. I'm talking large scale, residency level, after residency. That mentor is really a chance to start that process on a good foot. And it's a chance to engage with future colleagues. I'll get to a little bit more detail on this a little bit later. Productivity is another factor. It is important to get productivity items out of your research. Things like papers are important. Things like presentations are important. Things like posters are important. Papers can be really, really random. People told me this early on, and I kind of registered it. Now, after the full experience of trying to put papers through, the science and your writing is really only, I'd say, about 2/3 of the paper. The other third is, bluntly speaking, politics. There's a lot of things that go on in the background that you have to spend time and effort going through to get that final paper. So some people get very lucky and they do the hard work of the research, they do the hard work of writing the paper, and that politics part just kind of doesn't happen that cycle. For whatever reason, the reviewers on their paper weren't competing with them, so everything was fine. So that's great. It's great to get a paper out of it. If you don't necessarily get a paper out of it, it's also great. The key part that I've noticed is productivity in the sense of getting excited about a topic is something that you can translate into something that helps you in residency, helps you in residency interviews, it helps you in your career. So productivity, open up your mind for what productivity actually means. And I will talk about that in a separate slide as well. Learning skills is very important. So learn a broad set of skills. Learn skills that you've always wanted to learn but never had time to learn. These kind of things follow you no matter where you go. And if you learn those skills in a way where you're anticipating what's going to be big in 10 years, you may not have a paper today, but you will be one of the few people that has 10 years worth of developing that skills. And later on, that's very, very valuable. And finally, the law of diminished returns, which I'll talk about in about 2 slides. And it's really important to consider, where are you going to put your efforts? Where are you going to put your efforts so that you achieve your goals? And there are some excellent resources out there for how to write case reports. I think someone else covered this as well, but I won't really cover this too much. Leverage these resources. There's just one example on this PowerPoint. And leverage these examples to figure out what you need to do on the ground to write papers. It never hurts to know how to write these papers, and try your best to write these papers and submit those papers, but don't necessarily be disappointed if you don't end up able to write those papers or able to see those papers go to publication. It's a slow process. All right, so a good mentor is the thing that matters the most. I would say hands down, a good mentor is critical to having a good experience in research and for setting up a research career. I would start reaching out to mentors immediately, absolutely immediately, because good mentors will never take it personally when you engage with them, actually have interest, and then say, you know what, this is not for me. I think I'm going to go do something else. I still keep in touch with mentors that I went and spent 2 weeks with, didn't like the work that I did in that lab, went and did something else. I still keep in touch with them because something drew us together in the first place. So we can leverage that and keep an eye open for where we can collaborate in the future. But never hesitate to reach out to faculty mentors, especially at Emory. For the most part, everyone is incredibly friendly and everyone's incredibly open, and they take the opportunity to transfer their excitement for their field to you. Start that day one. Your mentor is a chance to get exposure to medicine and physicians that you wouldn't otherwise get a chance to see. It goes a little bit with the first point. Go talk to someone that you think you might be interested in their field, and maybe spend a day in clinic with them, maybe try to write up a paper with them. Don't beat yourself up if you can't see that to completion. But in that process, you'll actually learn a lot about whether that specialty is for you, whether those physicians are your people, and things related to that. Find someone that you resonate with regardless of topic. This I cannot stress enough. That figure up on the right is very important. A good mentor listens. A good mentor communicates clearly. They inspire you in the sense that when, not if, when your research project turns south, which it will, if it's a real question, it will turn south. They need to be able to keep you going, and they shouldn't be kind of taking things away from you. They should be giving energy to you. They help set goals. They're accessible. They want to talk to you, and they give good feedback. And the teaching is variable these days. We have a lot more resources online. So having a mentor that guides you through what resources to look at, I think, is a good way to find a mentor. A mentor should never, ever discourage questions. So I was a little bit shocked with coming back from the PhD into third year because of the nature of questions. And sometimes I would ask questions on the wards that would come across as challenging the knowledge that everyone had. Use discovery as an opportunity to learn how to ask questions in a sincere way, but in a way that you're not afraid to ask the questions. And a good mentor won't discourage questions. They'll actively like the questions that you have. So go talk with people, start reaching out M1 year and just ask them questions about the research, and then ask them questions about, well, what if that's not the case? Or, well, what if this assumption is wrong? And see how they respond. If they respond in a positive way, that's a really good sign. If they respond in I just told you what the truth is, why are you asking me a question? Then that's not the best sign. It's an art to ask questions. It's an art to ask questions. It's not a challenge to authority in discovery and in the research world for sure. And then separately, find a way to challenge authority. Find a way to actually have that friction with your mentors, because a lot of really cool ideas come when you ask your mentors to not think what they think. Like, think outside of the box that they've set up for their research. And that's actually the spark for a lot of really good ideas and really good research projects. Most important to capture all of this is that they see you as a colleague. They see you as a future colleague. They see you as an active colleague right now that they're helping train, not as someone that plugs into some work and finishes the last little bit of someone else's project. Push yourself with research projects. So I'm at 16 minutes. I'm going to try to speed it up a little bit. Find out what interests you. What skills do you want to learn? Really, I would ask that first. What are your interests? And then what skills do you really want to learn? From that set, go to a department that you're interested in and find which faculty member or which project comes closest to the thing that I want to learn to do. Too often I see folks go to whatever project is available and go to that project and not ask themselves what interests me, and then compromise, find that middle point between what the mentor needs you to do in the project and what you want to do, because that's the way to a healthy mentor-mentee relationship. Is both of you are working towards something, but both of you are actually achieving your own individual goals, which almost never align. And the last thing is law of diminishing returns. I can't stress how important this is. This is the general principle that to go from 50% up to 70% in terms of output, productivity, quality is much, much easier than going from 70% to 90%. So here, L1, L2, is, if you think of the x-axis as effort, then to get from here to double is not too much. You don't have to do too much effort. To go from L2 to L3, something like 70% up to 90%, it takes a lot of effort. Keep in mind, you only have 5-6 months if you're on discovery. You only have 5-6 years if you're PhD, but this applies across the board. Do you spend all 5 months on one thing, trying really, really, really hard to get to L3, knowing that it's going to take even more effort just to make a little bit of progress? Or do you spread your effort over several things? Do you get yourself up to L2, get yourself 70% of the way there in one skill, and then switch gears to a different one? Because with the same amount of effort, you can get to 70% in a second skill, or in a third skill, and a fourth skill. So in 5 months, you'll find yourself actually gaining a lot more skills, but potentially reducing the probability of you having a research product on the end. There is a caveat to that. So figure out your goals. Do you want to be productive? Nothing wrong with that, but I think you miss out on this opportunity to really catch research, catch the excitement of research. Or do you switch gears and learn new things? Because this is a dedicated 5-6 months where you can learn new things. No one will ever really hold you to the mistakes you make in those 5-6 months. So it's your chance to make mistakes and learn from those mistakes. Think long-term skills, not necessarily short-term results, would be my take on it. So real quick, when deciding on my PhD project and mentor, I went to the mentor that I resonated with the most. They had a project that was already ongoing. It was deep brain stimulation for depression. They had patients ready to go. They had an experimental setup ready to go. I came in and offered to collect data in the way that they wanted, but with the analysis approach that I wanted. I came in with a very different background than everyone else. So I said, sure, I'll collect the data, but I want to analyze it this way. And the reason I wanted to analyze it that way is I had different goals than the lab had. So the work that I got during my PhD, that data still follows me. I still have that data, but I'm able to take it to a very different project. Everything on the right is actually computational. It's all on the computer. The middle is the data that was collected from patients. So realize that the thing you do in discovery can last for a long, long time, and you can really keep the data being productive. You want to choose a discovery project that lets you talk passionately in research, in residency interviews, something that lays the foundation for long-term projects. You want to focus more on mentors and skill than the specifics of the research project. A specific research project doesn't matter as much as the skills you gain in trying to achieve a goal. Maximize your chances of posters at conferences. Posters and conferences, those are two very important places that you make connections. So how do you leverage the fact that you're doing all this work to engage with people that might even interview you for residency? Papers are a crapshoot, so I wouldn't bank on papers. Don't go in saying, 4 months, I'm gonna get a paper out. You could, but more likely you're not going to. All right, and Discovery, I'm just gonna do a shameless plug here. Discovery is a great chance to actually learn machine learning. That's a very exciting topic right now. It's a topic that changes the way we do research. It's also a topic that I strongly believe will really force us to rethink how discovery is done. It's much easier to get a machine learning based project done in 5 months than it is a basic science project and maybe even a clinical research project. We can talk about this more later. Feel free to reach out to me, and we're actually going to do several workshops online, but then hopefully in person once everything settles back down, to actually do machine learning teaching for medical students. So with that, I'm ending with any questions are welcome, and we might have to just postpone that for email and comments. And as always, feel free to email me or tweet at me. Cool. You're muted.
All right, thanks, Vineet. Has there been any machine learning courses yet, or that's still in the works?
No, we'll probably have the first general workshop in 2 weeks. So we're finalizing some of the machine learning medicine stuff, and